It would detonate and obliterate all of New York City, parts of Connecticut and New Jersey. This is perhaps one of the best-kept secrets in our material science. Betelgeuse, a magnificent miracle gracing the night sky, is a well-known, exceptionally massive red supergiant star. It resides in the Orion constellation, astonishing stargazers for centuries. Following insights from renowned physicist Michio Kaku, concerns have arisen suggesting that Betelgeuse might have finally detonated. What this means for reshaping our understanding of stellar life cycles and the forces shaping our universe is a critical question. What secrets does it hold for us? Stay tuned to find out. Imagine looking at the night sky and seeing a brilliant star in the Orion constellation. Betelgeuse, also called Alpha Orionis, is a massive luminous body located at around 5 hours and 30 minutes, right ascension and zero declination. Its name originates from the Arabic term meaning the giant's shoulder. In 1603, astronomer Johann Bayer gave the star its remarkable name, Alpha Orionis, signifying its prominence as the most conspicuous star in the Orion constellation. Interestingly, despite its fame, Betelgeuse is a red supergiant with a mass several times greater than our Sun, making it a true giant compared to our solar system. To put this into perspective, if the Sun were a small marble, Betelgeuse would be an enormous ball. Determining its distance has been challenging, with estimates ranging from 500 to 600 light-years away, a considerable distance in cosmic terms. Betelgeuse shines brightly, with an apparent magnitude of around plus 0.6. Harvard professor Morgan McLeod observed that its size and proximity make it one of the few stars that astronomers can study closely using telescopes on Earth and in space. Telescope images reveal Betelgeuse's unique features, showing a surface markedly different from the Sun's smooth appearance. Instead of a uniform sphere of extremely hot plasma, Betelgeuse appears as a patchwork of turbulent, frothy gas pockets, some nearly the size of smaller stars. Massive eruptions of hot material rise from Betelgeuse's outer layers, resembling cosmic spring cleaning. One such eruption is so massive that, traveling at the speed of light, it would take 75 years to cross it. This phenomenon, known as a surface mass ejection, releases material from Betelgeuse's outer layers, similar to the Sun's coronal mass ejections. However, these ejections vary in intensity due to Betelgeuse's internal cycles. At just 10 million years old, Betelgeuse is relatively young compared to our Sun. Despite its youth, it has already exhausted much of its hydrogen fuel at its core and entered the later stages of its life as a red supergiant. During this phase, it fuses helium into carbon through nuclear fusion, driving rapid structural changes fueled by its immense initial mass. Scientists believe that Betelgeuse started its life as a blue-white star, part of the largest class of hydrogen-burning stars. A star's size directly correlates with its brightness and energy output. Larger stars like Betelgeuse burn brighter and faster, leading to quicker hydrogen depletion and a shorter lifespan. Betelgeuse's surface reaches scorching temperatures of up to 8,950 degrees Fahrenheit, a stark contrast to the Sun's cooler 10,000 degrees Fahrenheit. As it exhausted its hydrogen and began fusing helium, its outer layers expanded dramatically, making it one of the largest known stars, with a diameter exceeding 700 million miles. Currently, Betelgeuse's surface temperature is around 5,800 degrees Fahrenheit, cooler than the Sun but vastly more luminous, being 7,500 to 10,000 times brighter. In 1836, astronomer John Herschel observed fluctuations in Betelgeuse's brightness, leading to its classification as a semi-regular variable star. These irregular changes typically follow a 400-day cycle. However, in 2019, Betelgeuse exhibited a peculiar anomaly, deviating from its usual behavior. Its brightness dimmed significantly by around 60%, marking an unprecedented event. This dimming was linked to a massive release of material that formed a dust cloud, temporarily obscuring the star from our view. While the dust cloud eventually dissipated, Betelgeuse hasn't fully returned to its previous state, and its brightness cycle has shortened to just 200 days. Betelgeuse's erratic behavior has sparked discussions about the possibility of an imminent supernova. In a supernova event, the star exhausts its remaining fuel, causing its core to collapse and forming either a neutron star or black hole. Its outer layers are then ejected at incredible speeds, up to 25,000 kilometers per second. If Betelgeuse were to go supernova, it would be a spectacular event visible for months, rivaling the brightness of the full moon. At just 650 light-years away, it would be one of the brightest supernovae ever observed. While star explosions are common, they are typically too distant to be visible without powerful telescopes. Betelgeuse's potential supernova would be an unparalleled event for sky watchers. Historically, the most recent naked-eye supernova was SN 1987A, observed in 1987 at a distance of 168,000 light-years. While this event provided critical insights into stellar evolution, its distance from Earth meant it had no significant effects on our planet. Betelgeuse's eventual supernova, though a cosmic spectacle, poses no threat to Earth due to its relatively safe distance. The explosion might cause a temporary surge in ultraviolet radiation, potentially leading to minor ozone layer depletion, but this would likely be brief and have minimal ecological impact. Shortly after the explosion, Earth would detect a stream of neutrinos, harmless particles emitted during the supernova. The star would brighten dramatically, matching the glow of the full moon within weeks. Betelgeuse's brightness would then wane over 6 months to a year, providing a stunning display for stargazers. Whether Betelgeuse explodes tomorrow or in 100,000 years, its eventual supernova will mark the end of an extraordinary chapter in the cosmos. Humanity will have a front-row seat to one of the most magnificent stellar phenomena, a reminder of the dynamic and ever-changing nature of our universe. Once Betelgeuse exhausts its final reserves of fuel, the core collapse will set off an incredible chain reaction. The energy release will create shockwaves that propel the star's outer layers into space, forming a vibrant supernova remnant. This remnant, composed of heavy elements like iron and gold, will scatter throughout the cosmos, seeding future stars and planets. For astronomers, Betelgeuse's supernova would be a once-in-a-lifetime opportunity to study the dynamics of such an explosion in detail. Advanced telescopes and instruments, such as the James Webb Space Telescope and others in orbit, could capture invaluable data on the event, deepening our understanding of stellar death and the creation of elements. The surrounding region of space would also undergo transformation. The explosion's shockwave could trigger star formation in nearby molecular clouds, a process that plays a critical role in the galactic life cycle. However, because of Betelgeuse's relatively safe distance from Earth, the energetic particles and radiation produced by the supernova would likely have no severe impact on our planet. As Betelgeuse dims over months and years, its absence will permanently alter the familiar visage of the Orion constellation. No longer will the red beacon mark Orion's shoulder, a loss that underscores the transient nature of celestial landmarks. However, this change also serves as a profound reminder of the interconnectedness of the universe. The elements forged in Betelgeuse's core and scattered through its supernova will eventually contribute to new stars, planets, and perhaps even life. Looking ahead, the question remains, when will Betelgeuse explode? While most estimates suggest a timescale of 100,000 years, recent studies hint it could happen sooner, possibly within the next 1,000 years or less. These uncertainties stem from the complexities of stellar evolution, where slight variations in mass, composition, or internal dynamics can lead to vastly different outcomes. Betelgeuse's behavior continues to intrigue scientists. The mysterious dimming events, unusual brightness fluctuations, and possible changes in its color provide clues about the star's internal processes and impending fate. Each observation brings us closer to unlocking the secrets of one of the universe's most spectacular phenomena. Until that day comes, Betelgeuse remains a stellar giant, both in size and significance. Its eventual supernova will not only illuminate the night sky, but also illuminate our understanding of the cosmos, enriching humanity's quest to comprehend the universe.